Hi, welcome to Solving Systems of Equations by Elimination. Let's get started. You have your notes in front of you, and our steps indicate that we should be doing making sure that all variables are on the same side. This is different than when we were graphing. We want to make sure our x and our y is on the same side of the equation. We want to decide which variable we can eliminate, and you'll see one will lend itself to being eliminated more nicely than another. X or y were going to be eliminated. We're lining up the variables directly under each other, and we're going to add the equations to eliminate the chosen variable, checking the answer in both of the original equations. Let's begin. Remember that our goal is to eliminate one of these variables. Now if we look at our two equations, x plus y equals 5 and 3x minus y equals 7, we can see that our y's, when we begin adding these two equations, will nicely drop out. A plus y and a minus y gives me a 0. 3x plus x gives me a 4x, and my constants added together give me 12. Solving for x, I get 3. Well, I'm not done. I'm halfway there, but now I have to find my y. How do I do that? Kind of like finding b. To find y, I'm going to use the x in one of the original equations. So I have x plus y equals 5. My x I'm getting from here, so it becomes 3 plus y equals 5. Solving for y, I wind up with 2. So my point, and for lines it was, when we graphed it was the point of intersection. This is considered the answer for these two equations. We check it the same exact way. We plug it into the original equations. And see if both sides equal each other. There is my x, there is my y, and both sides do equal each other on this side. Substituting for my x minus my y, 9 minus 2, and yes, both sides do equal each other. Therefore, this is considered a solution to this system of equations. So, it is somewhat different from our graphing lines. In graphing, we had to get it into y equals mx plus b, but in this way of solving systems, we want both variables on the same side. Let's try another one. In our first equation, both variables are not on the same side, so I want to get them on the same side. I'm going to rewrite that equation over here so I can manipulate it. I'm taking my 2x and I want to bring it over with my y. Using inverse operations, I wind up with an equation that looks like this. Bringing my other equation down directly underneath, lining up my x's and my y's, and I look at it very carefully. And what I see is I do not have inverse operations on my y's. So I want to direct your attention to the arrow, and the arrow is telling us sometimes I will have to add the opposite in order to get the terms to be opposite of one another. And I want you to think about when you have a negative in front of the parentheses and you distribute that negative to every term inside the parentheses. It changes every term to its opposite. So you can choose one of the equations and distribute a negative throughout. So I'm choosing my first equation. I'm going to put a negative outside of the parentheses and distribute that negative to every term inside the parentheses. And it will look something like this. Negative 2x minus y equals negative 7. And I'm just sliding over my other equation, and I'm going to add those together. When I add these two together, my y's drop out, and I wind up with 2x equaling negative 2. Solving for x is going to equal negative 1. There is one of my solutions. Now I want to substitute in that x equals negative 1 into one of the original equations. So to find y, I'm going to use my x, write one of the original equations, show my substitution, and solve for y. And let's check this point. I now have a point that is negative 1, 9, and I want to check it. I think I gave you plenty of space, and we're checking it in the original equation. So I'm checking negative 1, 9 in the original equation. Y equals 7 minus 2x. Y is 9. 7 minus 2 times negative 1. 9 equals 7. Negative times a negative now is a plus. 9 equals 9. It checks in the first equation. Let's check it in the second equation. The equation is 4x plus y equals 5. Show your substitution. And it does check. 5 equals 5. I want you to take this opportunity to work on this practice problem. You want to look at the variable, and it looks like your y's are opposite one another, so I would choose those to eliminate first, add these two equations together, and see what you come up with. Pause here. Welcome back. Let's take a moment, and when we add our two equations together, our y's do drop out, and we have 3x equals 15 and x equals 5. I now want to find my y. going to use my x, which I found to be 5, in one of the original equations. Write the original equation. Solving for y. And I'm going to check my point. Now again, if we were graphing these lines, that would be the point of intersection. So my point is 5, 4. Let's check 5, 4. Original equation, before you've manipulated it to move it, substitution, do both sides equal each other. First equation checks. I'm sorry, that should have been a 2. Second equation, write the original equation, show your substitution, and both sides check. I want you to try number 2 and do the check independently, and we will see how you did tomorrow. Good luck.